So we continue talking about 4.3 here, and we're going to talk about the second derivative test for relative mins and maxes, local extrema. So if f prime of x is 0, so that means we're going to have a horizontal tangent line, and if the second derivative is negative, that combination of things guarantees that we must have a relative maximum at that point. So a horizontal tangent, and then concave down is what that second derivative is telling us, means we're going to have a relative maximum there. And likewise, if the first derivative is 0 and the second derivative is positive, we get a horizontal tangent at the same place. The function is going to be concave up, so that's going to force that point to be a relative minimum. Now, be careful if the second derivative is negative. So then it really truly is inconclusive. Anything could happen. And we can see that with a few examples. So with f prime of x equals x cubed, we know what the graph looks like. And clearly at 0, there is neither a relative min nor a relative max. That's actually a shelf point. But we can see that f prime of x is 3x squared. F double prime of x is equal to 6x, and so f double prime of 0 is 0, as is f prime of 0. So here's an example of where the first derivative is 0, there's a critical point there, and the second derivative is 0, so we just don't know what's going to happen. Same thing with x to the fourth. The first derivative of x to the fourth is 4x to the third, and we know that that will be 0 at 0. And the second derivative is going to be 12x squared, and the second derivative at 0 is 0, which means we don't know what's going on. In this particular case, it turns out there is, in fact, a relative minimum there. And in the case of negative x to the fourth, then we get that again, this will have a critical point at 0, because 0 makes that first derivative equal to 0, and likewise, the second derivative evaluated at 0 is 0, but we can see here we have a relative maximum. So there are three different cases here, each with the first derivative 0 and the second derivative 0, in which case anything can happen. There could be no relative min or max, there could be a relative minimum, or there could be a relative maximum. And so that's why the test truly is inconclusive when that second derivative is 0. Let's look at the next panel. So here we have a derivative of a function is going to be 4x cubed minus 12x squared. So first, can we find the x values of any local extrema? So we can set this equal to 0, and if we factor out a 4x squared, what will remain is going to be an x minus 3. So we have critical points at 0 and at 3, and we can, in this case, let's go on and do our second derivative test. So our second derivative is going to be 12x squared minus 24x. Sadly, if we evaluate this at 0, it's 0, so we don't know. We're going to have to do the first derivative test after all. Let's try evaluating at 3, and we'll get 3 squared is 9, 9 times 12 is 108, and 3 times 24 is 72, so we can see that's going to be positive. That means it's concave up. That means that we're going to have a relative minimum, and that's the best we can do is say is x equals 3. We don't know the y coordinates. So we're going to have to come back now and do the first derivative test around 0. So here's 0, here's 3. So if we plug in something to the left of 0, say a negative, this is always going to get squared and be positive. A negative 1 minus 3 is negative. A positive times a negative is negative. If we plug in a positive 1, the 4x squared is still positive, but the x minus 3 is still negative. The product's still negative, so that's going to be a shelf point. It turns out that it is not a relative min nor a relative max. So the only relative extrema is going to be at x equals 3, where we're going to get a relative minimum. Okay, let's go on. Let's find the intervals where f is increasing and decreasing. Well, we started that work. We have negative, negative. Let's plug a number in that's bigger than 3. So this is, again, always going to be positive. If we plug in 4, that'll be positive. And so now we can see that it's positive to the right of 3. So the function is going to be increasing for x greater than or equal to 3. Remember, you include the endpoint on increasing, decreasing. It's going to be decreasing for x less than or equal to 3. For concave up, concave down, we have to look at that second derivative. And so now we're going to have to look at we need the signs on that. So here was our second derivative, and we can take that 12x squared minus 24x and set that equal to 0. We can factor out a 12x, leaving behind x minus 2. So we're going to get x equals 0 and x equals 2 are pips, potential inflection points. So we can now analyze the sign on the second derivative. I guess I should have called this the first derivative over here. So we are going to, if we plug in a -1, that'll be negative, that'll be negative. The product will be positive. If we plug in +1, that'll be positive. X minus 2 will still be negative. Product will be negative. And if we plug in 3, they'll both be positive. So we can see that f will be concave up when the second derivative is positive. That's going to be for x less than 0 or for x greater than 2. And it's going to be concave down when the second derivative is negative, and that's going to be for x in between 0 and 2. So see if we can try to figure out what might be a graph of this function here. And it looks like 0, 1, 2, well, we need 0, 2, and 3 are going to be points of interest at least. So let's see, to the left of 0, well, we have a relative minimum at x equals 3, so that's going to be a low point somewhere down in here, I think. And it's going to be decreasing to the left of 0 and also be concave up. So I'm going to say that's going to go decreasing and concave up. I don't know any y values, so I'm just picking the origin there. Then from 0 to 2, it's going to continue to decrease, but change to concave down. So that's going to look something like that. Then from 2 to 3, we still have a negative first derivative, but now it's going to change to concave up. And that doesn't sound right. Oh, yep. I did that wrong because I was supposed to go to 2 with concave down. Then it's going to switch to still decreasing but concave up until I get to 3. Then after that, it's going to be increasing and concave up the rest of the way. So we can do that. Very good. Let's go to the next panel. And we've got here now, we have the graph of f prime of x here, and we know that f is continuous on this interval from -4 to 4. Can we find x coordinates of relative extrema? So we want to know where's the derivative 0 or undefined, and then where does it change sign? So here at -2, the derivative is 0, and it goes from positive to negative. So at x equals -2, we're going to have a relative maximum. Then at -1, the derivative is 0 again, and it's going to go from negative to positive. So we're going to have a relative minimum at x equals -1. Now at 0, we can see that the derivative is going to be undefined, but it's going to go from a positive to a negative. So an undefined derivative is a critical point. we do have a continuous function, and so that means at x equals 0, we're going to again get another relative maximum. Now it's going to be 0 again here at 1, and so that's also going from negative to positive. So we're going to have another relative minimum at x equals 1. And then here's another place at x equals 2 where the derivative is undefined and it goes from positive to negative. So that's going to be another relative maximum at x equals 2. This is going to be challenging. So let's see. We can see from negative 4 to negative 3, the derivative is positive, so it's going to increase. So I don't know what the y values are, but I'm going to just assume it's going to be here. It's going to increase, and because the derivative is negative, it's going to be concave down until I get to that relative maximum at x equals negative. I said negative 2. I think that should have been negative 3 here. I don't know if it'll let me change that. Yep, so I'm going to change that to a negative 3. Sorry about that. And then it's going to be negative derivatives, so we're going to decrease. And remember, when there's a relative min or max in the derivative, that's going to be an inflection point. So we're going to get to here, and then it's going to change from being concave down to being concave up. And when we get to negative 1, that's going to be our relative minimum. So I'm going to make just my left hand touching the screen. That's a relative minimum. We're going to increase until we get to 0, and that's looking like it's a positive slope. And so when we get to there, it's coming in positive from the left, but it's going to come out going negative. So that's going to be some kind of a corner point. So I'm going to try to make it not look too much like a cusp, and I'm going to decrease until we get to positive 1. X equals positive 1 is going to be a relative minimum. Let me make that a little more curved. So something like that. And then it's going to increase and go to positive 2, where we're going to have another corner point. So it's coming in with a slope of about a positive 1. It's going to leave there with a slope of about a negative 2. And then that's a horizontal line. So that means it's going to be a straight line with slope 2 and negative 2 until we get to the end at 5. And something like that. All right. Very good.